The third case is as follows. Third case, we have an integral of this form. As you can see that the function inside the square root is a quadratic in this case. So my p is linear and my q is a quadratic. Now in this type of questions, what we do is we will substitute ax plus b as 1 by t. Okay, let's take an example. Let's say we have been asked to integrate dx divided by x minus 1 root under x square plus x plus 1. Okay, so as I said, what I'll do is I'll take x minus 1 as 1 by t. So my dx becomes minus 1 by t square dt. Okay, now let's substitute t in terms of x. So when we replace x in terms of t, our integral gets converted into, our integral I becomes minus of dt 3t square plus 3t plus 1. Okay, now what I'll do is I'll try to convert this into some standard form. So to convert this into some standard form, I have a square root sign here. I'll take root 3 common. When we do that, I can write this integral as root under t plus half whole square plus 1 by 12. Okay, now you know that this is an integral of a standard form whose solution we can write it as minus 1 by root 3 ln of t plus half plus square root of t plus half whole square plus 1 by 12 plus a constant c. Now I'll replace t with x. Since x minus 1 is 1 by t, so t becomes 1 by x minus 1. So this becomes minus 1 by root 3 ln of 1 by x minus 1 plus half plus root under 12 x minus 1 by x minus 1 plus half square. So this is my final answer. Okay, now the fourth form. The fourth form deals with this type of integration, dx divided by ax square plus b root under cx square plus d. So the speciality about this type of equation is that here you can see that both ax square plus b and cx square plus d are pure quadratic functions. Okay, so what you do is that in this type of situation, you replace x with 1 by t. So your dx becomes minus 1 by t square dt. So do that. Let's take an example. Let's say you have been asked to integrate dx divided by 1 plus x square root under 1 minus x square. So what I'll do is I'll take x as 1 by t and my dx becomes minus 1 by t square dt. So replace x with t, and when you do that, your integration gets converted into minus 1 by t square dt 1 plus 1 by t square root under 1 by 1 minus t square, which when simplified becomes integration of, with the minus sign, integration of t dt t square plus 1 into root under t square minus 1. Now what we'll do is, see, we have t square and we have t dt. So you know that if I take t square as u, my 2t dt becomes du. So this can be converted into minus half du, and here you have u plus 1 root under u minus 1. Now you see this is of the form of integration of dx by p root q. So what we need to do here is that we need to get rid of the square sign. So again I'll make one substitution. I'll take u minus 1 as z square. So my du becomes 2z dz. Now replace u with z. So your integration becomes minus half integration of 2z dz z square plus 1 plus 1, and this is z. So finally you will get to integrate minus dz divided by z square plus 2. This is an integral, standard integral, whose solution is something of the form of tan inverse. So this integration gets converted into 1 by root 2 tan inverse z by root 2 plus c. Now what you need to do is replace z with u, replace u with t, and then finally replace t with x. Okay, so let's do that. My solution is minus half tan inverse z by root 2 plus c. My z is what? Z I can write as root under u minus 1, right? So this becomes root under u minus 1 by root 2. Okay, forget about all these things. I am trying to replace this part only, this part. And now u is what? U is t square. So it becomes t square minus 1 by root 2. And what is t square now? T square is 1 by x square. So finally this I can write it as root under 1 by x square minus 1 by root 2. So this is root under 1 minus x square by root 2 x square. So my answer is minus half tan inverse root under 1 minus x square by root 2 into x plus c. So this is my final solution. Okay. Next we move on to the fifth case.